NASA says its Pioneer 1 test, the most distant human-made object known to man, is sending usable information to Earth again. In the universe, we have no clue about what it is, with the exception that we can check it. Voyager 1, the famous space probe shipped off by NASA more than 4.5 decades ago, has recently sent back a message that has sent shockwaves through the academic community. After traveling almost 14 billion miles from Earth, Pioneer 1 has made a discovery so significant that it has redirected its mission towards our planet. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a priceless phenomenon, or something even more improbable? In this exploration, we'll unveil these revelations, as Pioneer 1 has recently made a disturbing discovery that caused it to unexpectedly pivot toward Earth. The Voyager twin probes, under specific circumstances, may have never left Earth. In this case, the aligning stars were the 4 biggest planets in our solar system. Close to 50 years ago, these planets were slowly aligning in a way that had last occurred during Thomas Jefferson's administration in the 19th century. This fascinating planetary arrangement initially went largely unnoticed. The first person to recognize its significance was Gary Flandreau, a graduate student in flight mechanics at the California Institute of Technology in 1965. While working part-time at NASA's Jet Propulsion Lab in Pasadena, California, Flandreau was tasked with figuring out the best method for sending a space probe to Jupiter or even farther to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these giant planets and made a captivating discovery. In the late 1970s and early 1980s, all 4 planets would align in such a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau determined that this alignment would cut the flight time from Earth to Neptune from 30 years to only 12 years. However, there was a catch. This planetary arrangement occurred only once every 176 years. To seize this rare opportunity, a spacecraft would need to launch by the early 1970s. NASA capitalized on this unique arrangement and built 2 spacecraft to make the journey, Voyager 1 and Voyager 2. The twin spacecraft embarked on an incredible mission to explore the outer planets of our solar system, thanks to Flandreau's visionary calculations. Voyager 1 launched on September 5, 1977, just a few weeks after Voyager 2 on August 20, 1977. Propelled by the powerful Titan III rocket, Voyager 1 began its remarkable journey into space, following a direct route. Their primary mission was to investigate the massive gas giants like Jupiter and Saturn, along with their moons. However, these brave explorers far exceeded expectations, venturing beyond our solar system and traveling farther and longer than any other spacecraft in history. The Voyagers broke numerous records, entering a region known as interstellar space, a previously uncharted area within our system. These probes, now more than 12 billion miles away, continue to astound scientists with their groundbreaking discoveries. Recently, a startling revelation from Voyager 1 shocked the scientific community. Initially, the Voyagers amazed experts with their close-up views of Jupiter and Saturn's moons, which astronomers had believed to be dull and heavily cratered like our moon. Instead, these moons turned out to be active worlds. Voyager 1 reached Jupiter in March 1979, just 18 months after its launch, followed by Voyager 2 in July of the same year. Equipped with VidCon cameras using filters to capture full-color images, the spacecraft were designed to rotate slowly, ensuring sharp, clear images. During their mission, the Voyagers captured over 33,000 photos of Jupiter and its moons, revealing fascinating details. For instance, Europa, one of Jupiter's moons, was discovered to have a fractured icy shell estimated to be over 60 miles thick. Saturn, the Voyagers parted ways. Voyager 1 navigated through Saturn's stunning rings, enduring countless impacts from tiny dust particles, before flying past Titan, a moon shrouded in orange haze. Meanwhile, Voyager 2 continued its solo journey, becoming the first spacecraft to visit Uranus in 1986 and Neptune 3 years later. Voyager 2's encounter with Uranus revealed 10 new moons and confirmed the planet's ring system. Despite these achievements, tragedy struck shortly afterward with the Challenger disaster, which claimed the lives of 7 astronauts, including Krista McAuliffe, the first civilian slated to go into space. 3 years later, as Voyager 2 passed Neptune, it documented the fastest winds ever recorded in the solar system, reaching speeds of 1,000 miles per hour. It also discovered Triton, Neptune's largest moon, which had surface temperatures as low as -235 degrees Celsius and icy volcanoes emitting nitrogen gas and particles into the atmosphere. Entrancing pictures of Neptune and its moons. Both rockets were booked to close down their cameras, denoting the finish of their authority mission. Anyway, cosmologist Carl Sagan, an individual from the mission's imaging team, intervened. In spite of the fantastic tour officially ending, NASA extended the mission with the hope that the spacecraft would venture into interstellar space. Renamed the Explorer Interstellar Mission, the probes were set to continue their journey into the unknown. Sagan persuaded NASA to allow Voyager 1 to take one final series of pictures. On Valentine's Day in 1990, the spacecraft turned its camera back toward the inner solar system and snapped 60 final shots. One of these photos, widely referred to by Carl Sagan as the pale blue dot, captured Earth from a staggering distance of 3.8 billion miles. In the image, Earth appears as a tiny spot, barely perceptible against the vastness of space, illuminated by a faint beam of light refracting off the camera's optics. "We've learned so much about the planets and moons in our solar system," Sagan said. "It's exciting to see how unique they are, even those that are the farthest away." Voyager's excursion beyond the heliosphere in August 2012 marked an extraordinary milestone. By venturing past the heliosphere, a vast region of charged particles released by the Sun, Voyager 1's exceptional feat became widely recognized the following year when a study was published in the journal Science. It's memorable to share Voyager's discoveries. The spacecraft's plasma wave instrument detected a strong solar emission between April 9 and May 22, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the probe had entered a region of higher particle density than within the heliosphere. At first, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, scientists explain that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. Analyzing Voyager 1's data, scientists pinpointed the official exit date as August 25, 2012. This determination didn't rely solely on electron movements but also on measurements of charged solar particles gathered by the spacecraft. On that historic day, coincidentally the same day Apollo 11 astronaut Neil Armstrong passed away, Voyager 1 detected a remarkable 1,000-fold decrease in solar particles and a 9% increase in cosmic rays originating from outside the solar system. These findings illuminated the dynamic and ever-changing nature of our cosmic neighborhood, showcasing the vastness and complexity of space exploration. Voyager 1 reached an astonishing distance of 11.25 billion miles from the Sun, around 121 astronomical units. At the same time, NASA's Planetary Science Division was diligently studying the solar system using diverse techniques, including flybys, orbiting, landing, and sample returns. The Voyager missions served as the pioneers and architects of this approach, laying the groundwork for future exploration. The Voyager spacecraft played a crucial role in studying the cosmos and shaping our research priorities. By conducting flybys, these missions significantly enhanced planetary science. The concept of gravity assist, using a planet's mass to alter a spacecraft's speed and trajectory, was fundamental to Voyager's successful exploration of the outer planets. Engineers and astronomers, in their quest to understand gravity assists, made groundbreaking discoveries, not just about the vastness of space, but also about navigation techniques. Alongside gravity assist, the Voyager missions relied on another critical component, the Deep Space Network, DSN. The DSN functions like a vast telephone line that keeps us connected to our daring Voyager probes as they venture into the unknown. What is the Deep Space Network exactly? It may not be as obvious as a spaceship, but it's undoubtedly vital. The DSN resembles an immense network of radio antennas spread across the globe, from California to Spain to Australia. These giant dishes, some as wide as 70 meters, act as space amplifiers, enabling communication with spacecraft far out in space. The DSN's role in the Voyager missions was pivotal. Equipped with cameras and sensors, Voyager became our eyes and ears in space. To process the data sent back and provide instructions, a robust communication system was essential. And that's where the DSN came in. When Voyager 1, traveling to the outer reaches of our solar system, sends a message back to Earth, it's a faint transmission racing at incredible speed through space. By the time it arrives on Earth, it's barely a whisper. However, the DSN's legendary antennas capture that faint signal and transform it into usable data for scientists. The DSN isn't just about receiving signals. It also sends commands. Missions like Voyager are dynamic, requiring scientists and engineers to adjust flight plans or carefully guide the spacecraft. These commands are transmitted through the DSN, traveling through space to reach Voyager. It's akin to having a two-way conversation between Earth and the most distant human-made objects in space. A remarkable aspect of the DSN is its constant operation, 24/7, always listening for those distant signals. It's more than just a collection of antennas. It's our vital space connection. The DSN keeps the stories of the Voyager missions alive, even as the spacecraft explore the uncharted regions of interstellar space. The long journeys of the Voyager spacecraft have been filled with unexpected challenges. Voyager 1, in particular, is equipped with 3 onboard computers, including a flight data system responsible for gathering information from the spacecraft's scientific instruments. This data is then sent to mission control on Earth in binary code, a series of ones and zeros. Recently, however, Voyager 1's flight data system seems to be stuck in a loop, repeatedly sending the same pattern of ones and zeros back to Earth. This issue was first noticed on November 14, when the spacecraft's communication unit began acting erratically. While Voyager 1 can still receive and execute commands from mission control, this issue means no new scientific or engineering data is being transmitted. NASA engineers have attempted to restart the flight data system, but so far, no usable data has been received. They are now working to identify the root cause of the problem before deciding on the next steps. This process could take weeks. Interestingly, this isn't the first time Voyager has had issues with its flight data system. A similar problem occurred in 1981. Despite these challenges, the Voyager missions have far exceeded their original expectations, outlasting any other spacecraft in history. While engineers work tirelessly to keep them operational, they also know that more challenges may lie ahead. Regardless of their dwindling power, the journeys of these spacecraft are far from over.